Can everybody see the slides?
Yep, we got it.
Great. Okay, so yeah, today I just want to cover briefly what kind of the landscape of DAST, whether it's applications, how applications are being developed these days, how DAST has been developed in the past, and how it's trying to meet those new kind of paradigms of how these applications are built, and just kind of go into a bit of the internals of Zepp, as well as really kind of dive into how DAST tools work. So that's pretty much the topics here. For those who are not familiar with who I am the senior security researcher at the vulnerability research team. I've been with GitLab for about 3 months now. Prior to that, I was doing DAST R&D at Veracode for about 9 years, 20 years in InfoSec total. Previously, I did a lot of internal browser research, so finding CVEs in Chrome and Safari and Opera and stuff. I've built a number of tools to kind of scan the top 1 million Alexa websites to identify security headers, how they're being used, as well as run some kind of, we're all familiar with retire.js that looks for JavaScript that's running in sites and to see if it's old or vulnerable. So part of that research for the Around the Web in 80 hours was to actually go through the Alexa top 1 million, inject JavaScript, pull out all the vulnerabilities like old versions of jQuery, and then report it on it. So yeah, a lot of browser internals, going through Chrome and Firefox source code more times than I can count. But yeah, so it's pretty much who I am. So for today's topics, just want to cover DAST for web apps, as well as web apps in the year 2020, because things have definitely changed. Cover a little bit of the Zepp inner workings and how it's kind of structured and some of the terminology it uses, and then briefly cover like false positives, true positives, and kind of the future of DAST at GitLab. So jumping right in for DAST for web apps, hopefully everyone has seen Dennis's walkthrough. He covered more of how DAST is being used within GitLab. Some really good information in there as well. He did cover a bit about attacks and things like that. I'll be covering a bit more as well. So for application scanners, there's really two types of DAST tools. There's a crawl phase and then an attack phase, which is what Zepp does. And then there's the other version, which does crawl and attack kind of at the same time. So Burp's, Burp Portswigger's Burp tool does the crawl and attack phase. I think, and I know NetSparker does it as well. Acunetics may, I can't remember. But there's really two different ways of doing it, and there's kind of pros and cons to each. So going into how DAST tools really work. So DAST tools are really broken down into 6 primary components. You have these components working together. Usually there's some sort of engine that kind of ties all this information together. And most tools these days use browsers to actually kind of automate the clicking and crawling of these attacks, as well as using a proxy to kind of capture that information as the site's being crawled. So we're going to jump into each component. The first one is kind of the state manager, and this really tracks what pages and parameters have been visited or audited. So a lot of times different plugins will be going off and doing their own attacks, or the crawlers going off and trying to find new web pages or new elements to click on. And the state manager kind of ties all that in to make sure that basically that's so that the scanner doesn't get stuck. There's obviously cases where if you're scanning a calendar application, you could end up scanning every month and every year and every day for thousands of years. So state managers also have usually some sort of deduplication logic built into them, so they can say like, okay, we've looked enough at a particular part of the website. Proxy is kind of the core feature of most DAST tools, where it's intercepting all the traffic from both the crawler phase and the attack phase. A lot of times, not only does the proxy need to modify for doing particular attacks. So let's say a browser goes to a particular web page, the proxy will intercept that first, and then it will do, if it's reached out to a plugin, the plugin will kind of modify the request that was about to go out and then send it off, modified for the attack, and then wait for the response, and then do some sort of analysis to see if there's a vulnerability or not. It can also do things like doing login management. So it'll actually look for if the the scanner is getting logged out. So it'll look at the response, pass that off to the logging manager and so forth. So the proxy really ties in all your network traffic is going to be going through that, so it can really get a good understanding and kind of coordinate all the different plugins and crawling and whatnot. So talking about the login manager, so this component really helps keeping the scanner logged in. There's usually cases where a DAST tool will have some sort of functionality where you can kind of re-log in. So some applications are more aggressive at logging things out. So for example, if you sent a request and it returned a 500 internal server error, some applications will say, oh, this person's clearly doing something that's wrong. I'm going to invalidate their session. So if you don't have some sort of login and session management feature, the DAST tool will basically go off, try to do its attacks, and then it'll be logged out. So none of the attacks are going to work. So it's kind of a key component of most scan engines. The crawler really is built, it really depends on the DAST tool. There's kind of two types. There's kind of the old type, which is send an HTTP request, get a response, parse out the HTML, look at href links or source links, attributes, and then pull out links, and then kind of feed that into a queue, and then keep going through and trying to crawl that way. Newer ones use, for example, Zepp's Ajax crawler or CrawlJax or Jax crawl, I forget what it's called. It will use more of the browser instrumentation. I think it uses Selenium, but usually what you have is the crawler is not only parsing the HTTP responses, it's actually looking at the DOM itself and pulling out events that have been bound to attributes. So for example, a button element may have a on-click handler. The crawler will be able to say, okay, search all the elements in this document that have this event bound to it, and try to click it and add that to its crawling queue. So they can get really, really complex, or they can be really, really simple. It all depends on the crawler's logic and components. Plugin managers manage loading these plugins. So there's usually two types of plugins. You have passive plugins, which are usually just looking at the proxy's response data and then kind of pulling out keywords, or looking, for example, like private information, PII, or maybe looking at server headers to extract the version information. So it's very, very passive. It's not making any additional requests to the system. The other side of it is the active plugins, or kind of attack plugins, which could either just be modifying requests as they go out from a crawler, or actually initiating their own kind of requests. So for example, doing directory brute forcing, trying to find additional directories, that could be a plugin. That would very much be an active type of plugin. And then you have your obvious cases of SQL injection, trying to take parameters and inject different SQL injection strings to elicit a response. The report manager is basically what it says. Its primary goal is to just collect all these reports or alerts from the tool, and then make sure that there's no duplication, hopefully, of reports, and then spit out a report at the end saying what type of flaws were found. Now, this could be either done inline as these vulnerabilities are found, or just at the end. Again, it depends on the DAST tool. So any questions on the components so far? No? Good. All right. So web apps in today. So there's a lot of challenges with web apps these days, especially since most DAST tools were developed or designed 5 or 6 years ago, where HTTP request and response was basically it. That's all you had to worry about. It was a lot easier to run these proxy attacks. Unfortunately, a lot of these tools have not kept up with the times. A lot of these new challenges come from things like the new single page applications. So these frameworks like React, Angular, Vue, and then there's a new one, Svelte, which I briefly looked at, but it looks pretty interesting, where it's a completely different paradigm as well. You have new protocols, so you have Speedy, Quick, WebSockets, WebRTC, API formats. GraphQL obviously is coming out, and if thinking about GraphQL, you're posting to a single URL the entire time. You're just changing your post parameters. If you think about the concept of doing deduplication on just URLs, it's going to look pretty useless because it's all one URL. And a lot of that can be said for REST APIs as well. And finally, you have complex authorization or just flows in general. So OAuth 2, which is a multi-step authentication. process JWT tokens, two-factor authentication, and CAPTCHAs. So a lot of things to kind of to make it much harder for a automated tool to really crawl or attack a website. So the way that crawling, I've kind of briefly already touched on this, but the way that crawling used to work was you would make a request, you'd intercept it, you'd parse the HTML, you'd pull out the URLs, and then you'd add that to a queue, and you would just continue on. Then we started to get into the kind of the AJAX revolution, or XML HTTP requests, where you do the same thing as above, but now you have kind of a browser that you're interfacing with to look for elements with on clicks or on post or other events that would be used to elicit responses and requests for a particular website. And then the last few years, you've kind of had a combination of both of these, but a lot of them fail because for single page applications, they no longer bind event handlers to just these individual elements. They actually bind it to the entire document. They're doing document rewriting, so they have their own event handler built into their framework, and it's all different depending on the framework. So you can no longer like load up a web page and then have all these nicely listed elements of which ones have on-click handlers on it. You have to actually understand the SPA framework to be able to really crawl it effectively. And so the solution most scanners take these days is literally just try to click everything and see what works, and then kind of go from there. So as I mentioned, these single page frameworks use a virtual DOM. So this is for performance reasons. So they're writing out their own kind of virtual version of the DOM, and then they're basically rendering it to the final page. So as I mentioned, this has the side effect of no longer binding these events. So for example, like you can't just, if there might be a div element that is actually a button, but it doesn't have anything bound to it, because when you click on it, the document event handler picks that up and then bubbles it up to whatever framework handling code it has. So what this ends up meaning is that a lot of client-side issues, such as cross-site scripting, are a lot harder because in some cases there actually is no network traffic. And if you remember, the components, the proxy is the primary kind of core feature of these tools. And if nothing's going through the proxy, the DAST tool has no idea that something just occurred. Some other kind of challenges with crawling is that there's actually simple things in DAST are actually really hard. For example, like even knowing when a web page has finished loading can be difficult, because even if you have, so there's this event called DOM content loaded, you would think that would be enough that the page has been loaded and you can say, okay, this page has been done. I can start clicking and going through it and whatnot. It's actually not true, because a lot of these frameworks are doing lazy loading of new JavaScript, or they're adding new elements to the DOM. What I've used in the past and what's kind of worked, but it's still not foolproof, is you have to kind of track the number of outgoing requests for the particular page that you loaded, make sure that it kind of increments and decrements down to 0, and then you kind of watch the DOM to see if it's changing. But if you think about a lot of these like carousel components that are modifying the DOM every second, it's going to look like the page is still being updated. So for a human, it's really easy for us to say, okay, this page has obviously been loaded and we can start navigating. For a DAST tool, not so much. And another thing that's really hard for scanners is that, and crawling in general, is that these days URLs are almost meaningless. A lot of cases, like this example of the snippets, like would you consider these two snippet pages different? I mean, they kind of are, but when you're thinking about doing attacks, it's not really different because it's the same core backend code that's being called. It's just a different URL. But again, for a DAST tool, that could be completely different page that needs to be tested. So you're going to be wasting a lot of cycles attacking these that are literally calling the same backend code. And then some more issues with crawling. You have state issues. So if you think about a website that has a vulnerability on page C, so the crawler is going to go to page A, and then it goes to page B. And during that, it's going to be adding state to your session. And then at page C, boom, you find some vulnerability, or there's some vulnerability that exists. So then during the attack phase, a lot of these tools will just try to attack C directly with a new session, but they might not be able to actually attack that because that state never got set by visiting page A, B, and then C. So without that state information, you're not going to be able to effectively find the vulnerability, because page C is just going to say you're not prepared to call my page yet. And then race conditions, obviously, these are fun. So a lot of DAST tools weren't built with concurrency in mind in the beginning. So a lot of them take too long. So they're like, okay, let's just add some more threads to it. So you add more threads or some sort of concurrency to it. And then you have these problems where, let's say thread A is attacking a page, or maybe it creates a document and then thread B is moving to that document, but then the thread A deletes that page out from under thread B, and then all of a sudden you can no longer attack it because that page doesn't exist anymore. And again, if you're keying off of URLs and you delete that particular URL, it's the other thread will not be able to attack it. And this actually happens with the crawl and attack phases being separated as well, where you have the problem of the crawler going through and creating up this really nice list of all these resources to attack. But then once the attack phase starts, these pages are no longer there or have been modified, or some sort of other state-related issue occurs between that time frame. So going to the attack phase. So for the proxy service, another kind of a challenge for these tools is, for every type of new format or framework that's used, these proxies need to be able to parse them and kind of split out the individual components of the request and then use that as an injection point. So provided nobody's colorblind here, the top part, you have these posts one. So you have the post directory, that's attackable. You can attack the path parameter. You have the one, which is the end of the URI that you can attack. You have the cookie values you can attack. You could also technically attack cookie names. You have JSON data, so you could attack the elements, and then you could have nested data types. So you could have XML inside of JSON, which you need to parse and treat differently. And as you're attacking that, you need to know how to re-encode that. You need to know where your attack goes in and fits in between those two types of data formats. So yeah, it's a lot of work to write parsers for all these different types of formats and ways that you can inject into a particular HTTP request. And then on top of that, you have a combinatorial explosion where you could have a very particular vulnerability that only exists with a particular combination of two query names or parameter names with very particular parameter values. So in this case, like the page is equal to admin, the datum2 is equal to dat. You might be attacking different parts of the query, but if it doesn't match that, then your initial attack will not work. So you have to attack each one individually in a combination of those different parameter values and names. So it can get really complex, and it ends up taking a lot of time because you have to go through each one of those. And then for client-side attacks, this is something that's a lot of DAST tools, and I think Zepp is kind of working on these more recently, but I don't know for certain if they're doing anything like this, where to attack these client-side single-page application frameworks, you really have two options. One is you can kind of hook the SPA framework and modify how it's loading or binding events. So you can kind of see what events are being bound to which elements and hook it that way to be able to crawl better or attack better. Or use some sort of extension or instrumentation of a browser directly to kind of listen for these changes. A lot of these frameworks will use URL fragments for doing their routing, their internal routing within the client side. So being able to listen for those events and then attack them that way is another possibility. But again, all just adds complexity to it. So the takeaway from all this is that DAST is really hard, and I did not even cover other issues like your browser's crashing, you're running out of memory, new JavaScript frameworks are coming up that completely rewrite how things work, user registrations. Yeah, there's just tons of different particular issues, and all these could happen at the same time or not at all. Network connectivity issues probably isn't too big of an issue for us because we're most likely going to be running in our own contained environment. However, you still might have latency issues. And a lot of these attack plugins will use something called timing attacks, where they send a request and they kind of wait for a response. And if it takes greater than 10 seconds, they say, yes, this is vulnerable. So if you have some sort of latency issues, that'll throw off those checks, and then it'll basically think it's vulnerable and alert as a false positive. So any questions so far? No?
So I have
Yeah.
one question on,
Yep.
you talked a lot about how this is so difficult. Is there any, are there any techniques to hint to the DAST scanner of like how to attack, or any standards or ways of piping in like, hey, here's the route you should follow. Here's the things that you should try to do.
Yeah. So, I mean, something that I know Cam and other people have been working, Craig and other people have been working on is the open API spec. So having that basically give you all the routes is great, and it's going to help significantly. The only catch, and I haven't looked at how Zapp's plugin works, is that sometimes those open API specs they have dependencies on data. So let's say you have a user object that has, I don't know, like a first name, last name, a different object. That object needs to be embedded in it. And it basically takes two requests. You have to make one request to get that username data, and then you need to use that in your second request. And if you don't have that data for that second request, the attack will not work. So what ends up happening is you're basically end up just fuzzing the open API, or the endpoints. And if you don't have a good understanding of the structure of those objects and how they all kind of tie in, then a lot of your attacks will fail. One thing that I did previously was I wrote an open API scanner where I would basically create it as a graph and say, okay, if I want to attack this endpoint, I need to request the data from this endpoint first and then use it to attack that one. So there's definitely things that we'll be able to do in the future. Open API is definitely going to help us be able to get some more coverage. And I think I'm going to talk about it at the end, but I think there's also tickets for using end-to-end testing to get us to be able to know which endpoints to attack. That'll help in the sense that hopefully the end-to-end test will contain the steps necessary to get the state to be able to attack it properly. But yeah, we that's definitely something that I think would help significantly. Yeah, because otherwise you're going blind and you need to use this whole crawling process to do it.
And another thing that I've seen a lot of, especially the newer DAST tools use, is a browser plugin specifically for these single page applications that will record everything that's going on in the browser and allow you to replay that in the DAST tool. So that's something else that could help.
Yeah, so, and I think Crawljax uses Selenium in the back end. A lot of these, there's really two ways that I've seen it as well, is you use Selenium, which is basically allows you to automate clicking elements and stuff and listening for that. If these DAST tools do have some sort of specialized kind of extension, which is what I did in my previous company, we actually wrote an extension to handle the coordination between the scan engine and the browser itself. So we would be able to listen to all those events that are happening within the browser. So yeah, it really depends on the DAST tool, but there are methods that you can use as long as you're kind of really tightly integrated with a browser, because you can't just do it inside of your engine itself.
But doesn't that also come with its own set of challenges? I know from my previous company as well, we wrote browser plugins or browser extensions, and with how fast browsers update,
yes,
we had to basically every week create a new extension. So
you are at the mercy of the browser vendors when you do that.
Yeah,
and
absolutely.
they are relentless in changing specifications. So one of the tools that I have, there's the DevTools protocol, which actually Selenium is using these days, and most browsers are moving towards this DevTools protocol. It changes like every day, like they're adding or removing new features from it, which if you're basing your engine off of it, you can basically get locked out and you'll no longer be able to do certain things within the browser. So yeah, it's definitely a risk. All right, so Zapp, just going to cover Zapp real quick. So Zapp, as most of you probably know, it's made up of a core team as well as contributors, and it's pretty much the best and pretty much the only FOSS solution out there. And as you saw, running and supporting a DAST tool is extremely difficult. So especially if you're doing this as open source on your own free time. So definitely want to give the Zapp team props for that. And before we kind of continue, I want to get some terminology down because it took me a long time to figure out Zapp's terminology. So just to make sure everybody's on the same page. So alerts is pretty much what everybody calls a vulnerability. These alerts are part of rules. Rules are your kind of checks that are to be done These actually create the alerts, and these are defined in the plugins. The plugin is in Zepp terminal is a Java extension or add-on extension that is loaded into the browser engine itself. This is actually stored in a different repository from the main scanner itself, so you can kind of side load in these plugins depending on the rules that you want to find for your particular scan policy. And your scan policy is just that. It allows you to define which rules are enabled and disabled for a scan. The context is a set of policies and actions, such as setting the URLs that you want to be able to scan, or the ones you want to exclude. So like you don't want it to attack the logout page, obviously. You would add that to the context. For authentication, you can actually set multiple credentials. So you could have like a guest user credential set, and you could have an admin user credential set, and you could scan both of them, and they would be done basically as separate scans, and then you could kind of do a comparison from that. You can also set custom scripts to run. Now, Zepp's scripting system is extremely powerful. I was really impressed to see it. You can pretty much rewrite anything. You can access the core scanner internals directly from your script. So you can pretty much do anything you want. You can access all the session information. You can access the proxy. You could write your own proxy within a custom script. So very, very powerful. And I do want to mention this is all happening within the engine. It uses something called Nashorn, which is a Java kind of execution environment for JavaScript. So you can take your JavaScript, it'll compile it or JIT it into a Java class, and then you can run JavaScript code inside of Java. For the context, you can also define which technologies you want to allow for your particular scan context. So if you're going to scan an application that's only written in C# that uses MS SQL database, you can actually go through and say, okay, I only want to do C# based attack or ASP.NET attacks, and I only want to do SQL injection against MS SQL. And what this does internally is it'll actually flip off certain logic or rules within the plugins themselves. If they are properly bound to, they have a kind of a tech policy that these plugins can kind of allow themselves to see and say, okay, if MS SQL has been defined, then I'll run this bit of code. And then at the end, you can filter these alerts so you can disable printing out unnecessary issues and so on. So that's kind of what the context is. So, and again, this is my understanding of Zepp. I've had, I don't know, maybe 3 weeks of really kind of looking at it. So I might be fuzzy on some parts of this, but the rules are defined in the policy. So if you wanted to do like SQL injection attacks, you enable the rules, that'll be defined in the policy. The policy kind of encompasses these active and passive rules as well as the context. The context can be exported to a file. So a customer could create a context and then hopefully re-import it into a Zepp scan. The credentials are stored in this file. The URLs are just stored in this. Login data, if it's defined as being a request, is stored in it. However, and this was a big catch and kind of surprise to me, scripts that you define are not contained in this file. So if you have a context that has a login script and a session script, these will not be in your context file, and you'll need to pass those in separately using a kind of insane combination of command line arguments that are, I actually never got it to work. I had to actually write using their Python API to get it to actually use the login and session scripts. So again, those are referenced by context. They are not included within the context file itself. So for authentication, Zepp handles authentication and sessions internally. As I mentioned in the previous component section, there's kind of the state management or the login manager, and this is what Zepp does. So this is really useful for detecting if a session's been invalidated, especially with a lot of the kind of newer applications that are using JWT tokens. What they'll do is they'll let you use the site for 30 minutes or whatever, and if they don't have some sort of automatic token updating routine, your token will become stale, and then you'll get a 401 unauthorized like token expired. So a session script will be able to kind of monitor the proxy and look for these responses and say, okay, I just got a 401 token expired, rerun the login script. So yeah, these two scripts kind of work in combination. The reason I think it was separated because the login feature could not be a script. It could actually just be a JSON post or form encoded post data of the username and password. And then the session script would be running in the background, monitoring the proxy traffic. And then if it detects it, it would say, okay, rerun that login data. So cookie-based sessions are really straightforward because they obviously, it's easy for it to, the browser will automatically set the cookie. It has something called like a cookie jar, which will resend the cookies every time. But with JWTs, that's no longer the case. JWTs are usually stored or sent in a authorization bearer header. That header usually is, the header token value is usually read from the browser's local storage or session storage cache or some other state within the framework. But what that means is that the browser doesn't really know about this, the internal browser does not really know about this session state information. It's stored within the framework. So without having this kind of session script to be able to run this, these headers will not be sent, and you will not be authenticated when you try to do various phases of the attacks. So what that means is if you're not using a browser to attack and your plugins don't, or your proxy doesn't understand that it needs to add this session, then it's not going to get sent with a request. So for the scan flow, and Dennis in his Brownbag session covered this a bit, obviously, because he was focused on this part, but just to cover it again. So the way scans usually work is you load Zepp, you use the API or a GUI to drive Zepp, and Zepp includes that kind of proxy service. You'd set a scan policy for your enabling, disabling rules. You'd set the context. It would run the crawler. This is kind of the kind of old school crawler, I'd call it, where it just looks for a ref links and pulls out links from responses and then crawls that way. And then if you did define to use the Ajax crawler, it would run that as well. Then it would run the attacks on the results from the crawler, and then it would run those passive rules to scan over all the collected data from all the different requests that went out, and then report it at the end of the scan. So any questions on kind of Zepp or parts of Zepp? Anybody want to add anything?
The one thing I would add, you mentioned the scripts.
Yep.
There's actually support. You can write the scripts in a variety of languages, including Python and Ruby.
Yep. And yeah, it all depends on what you include. There's also a Zest type of, which is basically kind of like a macroing. It's almost like Selenium recording of what you're clicking on, what you're doing. So you can use that as well. So cover a little bit of the future here. So for false positives and true positives, one thing I just want to kind of set straight here is some terminology. So, and I'm very guilty of mixing these up all the time. So a false positive is a finding that does not actually exist within the application, but it's just incorrectly reported as existing. Duplicate findings could be a legitimate finding that was found, but for some reason it's reported multiple times. And this happens a lot because if you think back to what I was discussing earlier, where URLs are almost meaningless, a lot of times the scanner will think this is a completely different unique URL, but it's really not. It's just a parameter's value has been incremented or decremented by 1. So that can be really hard for a DAST tool to understand that it's a duplicate issue. Duplicate false positives is kind of a combination of above, both from above. And these are probably the worst for a customer because they know it's false positive, but now they have to go through like 100 instances of why it was found. Insignificant findings, these are really kind of customer specific, like what I might think is a security issue, someone else may not, and vice versa. So this can be considered, and sometimes customers will say, oh, this is a false positive. It's like, well, it's not really a false positive, you just don't care about it. So having an understanding of these kind of 3 differences is important, especially if you're discussing with customers. So for false positives, the easiest solution is to reduce false positives. The easiest solution is just disable it. This obviously cannot be done in a lot of cases. We might need to do communication with people that we're going to disable it. The kind of process for this is to really investigate which of the rules FP the most and then just remove them or set up some sort of deprecation timeline for it. The best is to really investigate the rule, look at the logic in the plugin and see if it can be approved, and then push a patch upstream to get it patched to not FP as hard or as much. For duplicate findings, there's kind of two ways we could kind of handle these. One is to kind of filter the output, maybe batch up instances or ignore instances after it accounts once we find one instance of it. A classic example is like server headers. We might not want to report that the server is running Apache 2.4 on every single directory or page that it finds. We could just wrap that up into a single issue. Or we could do the other route, which is to investigate the plugin or logic again, and then push an upstream patch. For insignificant findings, we could disable the rule by default if we determine it to be insignificant. There are some cases that I've already identified that's like, okay, that might have been an issue like 10 years ago, but it's not really an issue anymore. This is going to require going through all the plugins, really understanding the logic, and then having some sort of discussion about what we want enabled or disabled. The best is really to have it easier for a customer to enable or disable these. So if there was like a checkbox, like, I don't care about server headers, check, and then they can disable it. That would be probably the best, because then it'll be very specific to that customer and their projects. So for the future, for coverage, Open API scanning is already in, which is great. That's going to help, especially as a lot of new applications are either built based off of the Open API spec or allow taking their API and exporting it as an Open API spec, which they can then feed into their other tooling. API discovery, I know, is something that's been kind of thrown around and discussed. And then I can't find the ticket, but using end-to-end tests, I think Cam made a ticket for this, where we would use Zepp proxy to basically run, the customer would run their end-to-end tests, Zepp would listen, do its attacks while it's listening. And actually, I just saw on the Zepp mailing list today, someone was trying to get it to work in GitLab. So I thought that was kind of interesting. But yeah, so I think, oh yeah. And also, if there is interest, what I could do another brown bag walking through the logic of each individual rule and plugin. So I've already gone through a lot of them just to pull out identifiers, but having a good solid understanding of how each plugin works, how it could potentially FP or have issues with duplicate reports might be beneficial. Worst case scenario, I do it myself and I just write up a document. Doesn't matter. So, any questions?
So just to comment, I personally would be interested in that. So even if it's just, however you want to do it, but I would definitely be interested in knowing that. I think it would help me with direction on where we're going with DAST and GitLab.
Yeah, absolutely.
Yeah, and I feel like we need to do that exercise anyway eventually to get a better product. I mean, I look at some of the rules and I'm like, what?
Yeah,
that seems ridiculous. And I'm not a security expert, so you know.
Yeah, no, you're right. Your intuition is correct.
Do you think there'd be any value? So one thing we talked about is running Zepp as a proxy when users run their end-to-end tests. Do you think it would be more useful to run Zepp with end-to-end tests, or use some kind of clever way to build a configuration file at the end of end-to-end tests that would help Zepp run, or help Zepp build post requests to REST URLs? Or
yeah.
Have you thought about any of that stuff?
Not too much. I mean, I feel like with the end-to-end test stuff, if the customer doesn't need to change any of their code, if they can just make a new stage and say, run your testing, but also just like add like enable DAST, and then they would do their normal testing stage or pipeline, but it would also be using Zepp to attack it. I think that would be pretty impressive and useful for customers, because they don't have to do anything extra except for define another stage. So does that answer your question?
Yeah, it does. I mean, I feel the same way. There's value in that. The only issue I have with it is often project teams don't run end-to-end tests on production-like environments.
Right.
So as an example, they'll be missing a load balancer, you know, which is probably potentially reporting the server version, which is a vulnerability.
Yeah. Yeah, that's true.
I mean, maybe we just provide choice, and they can choice in a recommendation, and they can just work it out themselves.
Yeah. Yeah, because I mean, there's a trade-off of running it against production versus just running it into your own little sandboxed environment. Um, I imagine in most cases when they're just changing code, they would obviously just want to do their sandbox environment. If they want to do like a monthly or quarterly thing, they would do against their production. It would be nice if we had some kind of statistics or metrics to say how often are people running against just instances, sandbox instances versus importing a live URL from somewhere like the environment URL text file that actually points to a live system. If we had that information, it would be probably much easier for us to prioritize saying, okay, everybody's just using DAST to attack their production once a month or whatever. It's like, okay, well then we would focus on that. But yeah, we'd need that data.
Yeah, unfortunately, that type of telemetry data is not something that is easy for us to get here. So, but I agree. I mean, that would be very valuable data. So that's actually, I'm working on some research projects right now that I'll be doing some interviews with a bunch of DAST users. And so that's one of the questions that I'm planning on asking them is how often, not just within GitLab, but you know, how often they run against a staging or product or development environment versus production.
Yeah, that'd be definitely a great question to ask.
Do DAST tools? Oh, I have a question. Do DAST tools integrate any other type of feedback mechanism to tell if they've made the target application do something new? I see a lot of overlap between fuzzing and DAST tools, right?
Yeah.
And so first thing that comes to mind is code coverage, but a lot of DAST tools are very, have a black box approach to testing applications. And so it's hands off and you may not even know what language the program is running in, right?
Yep. Yeah, so I mean, there's two kind of aspects to that. There's the one that most people have been leaning towards these days is IAST, the integrator, or basically you would have some sort of code or agent running within the application itself and have a DAST tool basically go through, run its attacks, run its crawling, and then that IAST tool would be reporting back to it saying, okay, you just hit these pages or you hit this particular issue. And then you have the whole RASP real-time protection stuff, which it's basically IAST, but it's blocking stuff. I mean, that's the way you'd want to think about the difference. IAST is, I haven't really seen too much of an adoption from it. This is just from my view. And the main reason is that it requires integration within live running systems as opposed to like just having a DAST tool, which is you just run the tool against it and you get results. It's a lot more hands-off by running a DAST tool as opposed to having some sort of feedback from a component. The only thing that DAST can really do is if it's tightly integrated with a browser is to have that feedback coming from within the browser instrumentation itself. So you could, for example, get coverage information on what elements have been clicked or what elements have events bound to it and go through there. But other than that, I mean, you're pretty much, that's all client side. It's not really server side stuff. So there's really there's no communication mechanism between the two that you could really use.
Has work been done around, or I'm assuming somebody's tried it. I'm not that familiar with DAST tools though. So what about like page load latency? Like when you, how you can guess passwords based on non-constant time string comparisons. Are there similar things like that for DAST tools?
Yeah, I mean, so you do have the concept of timing attacks. SQL injection uses it a lot, command injection as well, especially for like blind SQL injection where you can't get an error response back. What you'll do is you'll do one of two things. One, you'll send a very particular SQL injection attack string that calls some sort of sleep function. So say sleep for 10 seconds, and then you would wait for 10 seconds. And if the response came back after 10 seconds, you'd say, okay, this is vulnerable to that attack string that I just sent. The other one is other type of SQL injection attack is to do something called a heavy query, which is like you do a cross join of like 4 or 5 large tables and you just wait for like a minute. And if it times out, it's like, okay, yeah, that was clearly an attack that works. So there are those types of timing attacks that you can do. But yeah.
So not so much around trying to using it as a replacement for code coverage.
No, yeah, not that I've seen.
I don't know if it'll even work. Anyways, thanks.
Yeah. Yep.
So I have another question. Oh, you guys have?
Yeah.
So already.
The other vulnerability that I'm interested in is you talked about, like, as a proxy server, you don't see anything that's happening in a single page app if it's not hitting the server. Yep. So what I'm trying to understand is, what are the types of attacks where that's important? Because I would think a lot of the issues are sending bad data to the server or getting bad data back from the server, and then, you know, not escaping, things of that. So if it's just in my browser and you screw with my own, if I screw with my own browser, who really cares?
Yeah. So the problem is the URL fragments are not sent so that the hash symbol and then anything after the hash symbol, where is it? Yeah, this one. So after that slash, the hash symbol SPA route, that's not sent by the browser through the network. But if I sent you a link with that contain cross-site scripting, your browser will load it. It'll load the page, and then the single page application framework will load that fragment. And then, so basically, to answer your question, the only real attack is cross-site scripting. I mean, there's other small little things that you could do, like rewriting or redirecting and stuff, but for the most part, it's just cross-site scripting.
Cool, nice.
Yep.
So our security dashboard and our merge request widget, a lot of the value they provide is tracking vulnerabilities over time and tracking differences. You know, you change some code, you run a DAST scan, oh, there's a new vulnerability. Do you think DAST scans can be or are deterministic? Like, is that a realistic goal?
So determinism, and that's definitely something I've struggled before in the past, where especially once you add in concurrency, like threading and stuff, it becomes extremely difficult. There are basically techniques you have to use to kind of reduce the non-determinism of it. For example, the one thing that really helps is having the crawl phase and the attack phase at the same time, because you can run your attacks as you're crawling. Whereas with the crawl and attack phase, it's basically two different segments of time. And so that introduces a lot of non-determinism once you're splitting up by time. That being said, you still have the issues with these URLs that literally, there's no unique identifier. You need to take a combination of various aspects of a request to be able to come up with some sort of determining factor to say this request is unique because of this. That could be either identifying randomized or dynamic values and replacing them with like a static field, which is what I'm going to be doing for my benchmark stuff. You could be taking just the parameter names and then the parts of the path to create this kind of unique identifier. But yeah, to answer your question, yeah, it's I don't think it's 100%. It's always going to be kind of fuzzy when you try to match.
Yeah, fair play. I mean, my thinking about this was, surely it's dependent on the application. And I haven't yet worked out whether applications, we consider them to be deterministic or not in the way they behave.
Yeah, they're not. especially because determinism aside, you also have the issue that everybody's coding applications completely differently. So everybody has their own little quirks and unique flags and settings that they're so even if you have two React.js frameworks, like they're going to be coded completely differently. So that adds just complexity on top of the non-determinism.
So would determinism even matter though, if we're able to replay past inputs that we detected cause a vulnerability?
Yes, because for the state-related issues, that would be obviously kind of a requirement, because you need to have that state being set in a deterministic factor or method. The other, yeah, that's probably the main one.
Okay.
Yeah, and also
so
just having
was. Oh, sorry. Go ahead.
No, go ahead.
Oh,
I gotta collect my thoughts.
I was going to say if the state included the steps leading up to discovering a vulnerability, then determinism wouldn't really matter.
Right, as long as you had a deterministic way of replaying those steps, like, and that's the catch. Like,
Yeah.
if you are able to get to that, to rerun those steps, then that's what you need. So
Yeah, and I think that's how I would define determinism, that if you can rerun those steps and you're confident that you'll always get the same response, then I would consider it deterministic. But if we're not sure, then I wouldn't, and our security dashboard will be less useful.
Yep.
All right. Well, it sounds like we're running out of questions here. It did sound like there was interest in going through the rules and understanding those better, so we can, work to set up another one of these sessions or several to go through those.
Sure, sounds good. I got to do it anyways.
All right. Do we want to cover anything else before I stop the recording? And it doesn't sound like it, so I'll go ahead and stop it.